All right, some subtraction of scientific notation is up next. So we have subtraction with scientific notation. This is our last and final set of notes. As always, I am going to show you this through an example problem. Our example problem in this case is 5.3 times 10 to the third minus 8 times 10 to the second. Again, when we put this in perspective of what these numbers actually mean in terms of like orders of magnitude, how big they are, 5.3 times 10 to the third is like 5,300. 8 times 10 to the second is like 800. So I have a number written in the thousands minus 800, which is very doable. A lot of people, when they initially see this, they think, oh, I'm going to get a negative number. And you're not going to get a negative number because we need to look at the orders of magnitude here in terms of our powers of 10. I have thousands and I have hundreds place. So keep that in mind. We are going to start out with our steps, just like always. I'm going to write our 3 steps down that we need to have. They're going to be very similar to the addition problem steps. So it'll feel really similar to those. So the very first, make the numbers have the same place value. Okay, so in other words, same powers of 10. Okay, same place value. So just like before, I'm going to show this same place value with purple. Step number 2. After I've made the numbers have the same place value, this is an S by the way, this should say same place value, I am going to subtract the decimal. Subtract the decimals. I am going to show that in blue so you can see that. And then last but not least, just like all of the others, my step 3, rewrite in scientific notation. Simple enough. Okay? After you've gotten that written down, let's practice it. So here's our problem. We have 5.3 times 10 to the third minus 8 times 10 to the second. Very first, I am going to rewrite these in the same place value. All right, I have 10 to the second and 10 to the third. I'm going to break up this larger number because it's a whole lot easier to do. So that means I am shifting my place value 1 back. So that means I'm subtracting 1 in my exponent. So this number will become 53 times 10 to the second power. I still have this other number back here, minus 8 times 10 to the second power, that I can then manage. Now, next step, I have 53 times 10 to the second power. I need to do some subtraction. The subtraction I'm going to be doing is 53 minus 8, right? 53 minus 8 is, what is that, 45? Check my work. Is that 45? Yes, 45. My goodness, I don't know how I couldn't do that. But either way, I get 45, and then I still have my power of 10. They were both 10 to the second power. Now notice, I'm not adding these place values because 5.3 times 10 to the third is 5,300, and 8 times 10 to the second is 800. And when I subtract those, I'm going to get a much lower number. So I'm not going to do anything with these exponents here. I'm not going to turn this into 10 to the 0 or anything, or I'm not going to turn this into 10 to the 4th or anything like that, because first, this is being subtracted. These 2 values are being subtracted. These are only telling me place value. Whereas in the multiplication and division problems, I had repeated multiplication or division that I had to manage, and then I have an actual exponent rule that I can apply. In this case, these are just telling me place value. They are not helping me at all with actual exponent rules. So now I have 45 times 10 to the second power. I am now going to shift my place value back, and if I shift it to the left, I'm going to add 1 place value there. So I can now write my final number of 4.5 5 times 10 to the third power. And now I have my final equation or final number written out, 4.5 times 10 to the third power. And now it's all written out. That is the answer to 5.3 times 10 to the third minus 8 times 10 to the second. And that makes logical sense. 5,300 minus 800 would get me 4,500. So zoom out again so you can see all of this. Those are the notes that you need. Feel free to pause so you can add those and get all your color coding if you want to. But that is the end of our operations and scientific notation notes. Thank you for watching. Bye.